Okay, so why don't we get started now? I'd like to welcome you to the exida webinar, Alarm Shelving, Relieve the Symptoms of Nuisance Alarms and Create a Peaceful Control Room. My name is Todd Stauffer. I'm the Director of Alarm Management at exida. The audio for this presentation is over voice over IP. You are all muted. If you have questions or comments, please enter them into the chat or question box, and we'll go through them at the end of the presentation. A little bit of information about myself. I focus on alarm management here at exida. Been involved in the creation of the standards that exist on alarm management, in particular the ISA 18.2 standard. I'm an editor and voting member for that committee, so I helped write that standard, been involved since prior to 2005. Have also helped create some of the subsequent technical reports that provide some additional details on how to implement the requirements of what's in the standard. And my latest role is as the co-chair for a new group, a new standard being created on safety controls, alarms, and interlocks. So with that, why don't we get started? If you're not familiar with exida, we were founded in 1999 to make with a goal to make the world a safer place. And when I say world, I mean process plants from a functional safety point of view. We've expanded that out to now include cybersecurity and alarm management, all kind of areas to help mitigate risk in a process plant. We have programs for certification of devices and people related to safety systems, and we have a suite of software called Excellentia that is involved or helps guide you through the design process of safety instrumented systems and the functional safety lifecycle. One of the parts of that suite of software is called SIL Alarm, which is an alarm rationalization tool, and we consider alarm management to be an integral part of functional safety, so we consider it a part of the Excellentia suite. So in terms of today's presentation, we're going to talk about alarm shelving, what it is, what it's for, what its purpose is, how to apply it, what are the considerations that one might want to think about when trying to determine how to take advantage of shelving if it's in your control system. We'll talk about the requirements for shelving, what should be provided by your control system, particularly a new or a modern control system, so that you can actually evaluate what you have today versus what the standard says should be in your control system. At the end of the presentation, we'll actually go through an overview of how shelving works and how shelving is defined in 6 of the most commonly used control system platforms. So we'll be able to see how the DCS suppliers have implemented shelving within their respective platforms. Now, this material for this webinar comes from a new ebook that exida has just put out on alarm shelving. At the end of the presentation, there'll be a link provided for you to be able to download that ebook and get some more details on shelving and how it's used, and kind of a white paper educational style look at all aspects of it. So let's start with a reminder of what an alarm is supposed to be. It's in general, the DCS is typically able to control your process and keep it in the green zone, the normal operating zone, and that's what you want most of the time. However, when an excursion occurs and you go outside of that realm into the abnormal situation area, that's when you want an alarm. That's when you want notification to the operator that something has happened that requires their attention and response. And if that operator takes the appropriate response within the appropriate amount of time, the abnormal situation should correct and the alarm should clear. If the operator doesn't respond in time, then the process will continue to escalate, continue to deviate until we end up with a consequence or a shutdown. So pretty straightforward on what an alarm is supposed to be used for. So if you walk into a control room and you see that the alarm summary display is full of alarms, then there's something wrong. That means that the alarms that we see are not following the principles that we just talked about. In many cases, what we'll see is stale alarms, alarms that have been on the console for long periods of time. And how can that be? Either no consequence has occurred or the operator has responded and the alarm is not cleared. So an example of where the alarm as implemented is not following its purpose or its what it's supposed to do. So it's very common to go into a control room and see nuisance alarms. So first we want to talk a little bit more about nuisance alarms, because that's essentially the main reason for shelving to be used, is to be able to deal with alarms that are not functioning temporarily. So a nuisance alarm by definition is an alarm that annunciates excessively, unnecessarily, or does not return to normal even after the operator takes the correct response. And that kind of foreshadows a little bit of the human factors point of view of nuisance alarms. That means that if you implement a new alarm in your system and you train the operator on what they're supposed to do, the first time that alarm occurs, it's likely that the operator will respond appropriately. But if the alarm doesn't clear and it remains on the console and no consequence occurs, that would be very confusing to the operator. Now, the second time that alarm occurs, they'll probably still respond as they're supposed to, but you can imagine that at some point in the future, they're going to stop responding to the alarm because it's not making a difference. And they probably feel that their time and attention is better spent looking and dealing with other things. And that would seem to be a correct assumption if nothing is happening after they do respond to the alarm appropriately. So we can see here kind of the impact of, start to see the impact of what happens if we have nuisance alarms. Now there are a couple of different nuisance alarm types, different categories, and we want to go through them because that's relevant when we talk about shelving. The first type is called a chattering alarm. This is an alarm that goes in and out with a high frequency and is only an alarm for a short period of time. So you could find some alarms that go in for 1 second and then they clear, and then a little bit later it's 2 seconds and then they clear. Almost not even enough time for the operator to acknowledge the alarm. So obviously the alarm is not clearing because of action that the operator is taking, because they probably don't even have time to respond to it. So that can be quite annoying. And if you have chattering alarms, chances are the alarm horn in your control room is turned off because it would drive the operators crazy. Another type of nuisance alarm is a fleeting alarm, which is very similar to a chattering alarm, except it just does not repeat immediately. Another category of nuisance alarms is what we call bad actors. These are the alarms that create the majority of the notifications in your system. So you may have a control system with 10,000 alarms configured, but there are likely 10 to 20 of them that create 50 to 80% of all the notifications. So that can be a tremendous annoyance factor to the operator. And those could be chattering alarms, for example, could result in bad actors, but it can also be from problems with hardware and failures and things like that. And that's one of the key things I want you to realize with nuisance alarms is it's not only represent, or can not only represent a design problem that the alarm was not designed appropriately to begin with, but it could happen just from equipment failing. You were in the process of failing where you end up with nuisance alarms. And then the last category is called stale alarms. These are the alarms that are kind of constantly displayed on the alarm summary display. So when you walk in the control room, if there's the same cast of characters of alarms that are on the summary display and have been on there for days, weeks, or months, or maybe even years in some cases, those are stale alarms. Doesn't matter what the operator does, no matter what response they take, the alarm doesn't go away. So there's something wrong with that situation. And that can clog up the alarm summary display, making it hard for them to notice new alarms and be able to process alarms during an upset. So it's very important to try to get rid of the stale alarms as well. So one of the downsides to nuisance alarms, or let's talk about how that impacts the operator from a human factors point of view. And the first way we'll look at it is from what's called situation awareness, which is the ability for the operator to kind of take in what's going on right now and understand what that means in terms of how the process is working, where it's headed, and what will likely happen in the future related to the inputs that they see at that point in time. So they use their knowledge, their understanding of the process, the way things work together and interact. We'll call that the mental model. And they use that to really project out and understand what's happening. Well, you can imagine if the cues that they are using to start that understanding process are suspect or are false or unreliable, that's really gonna jeopardize their ability to truly understand what's going on with the process. It can lead them to incorrect conclusions. It can lead them to a misunderstanding of how the process works and what different information and inputs mean and lead to. And it can lead to mistakes. It can lead to operators performing the wrong action because they were misled by spurious information. So nuisance alarms really can impact the operator greatly in terms of their understanding of what's happening in the process. Now, what tends to happen if you have a lot of nuisance alarms is the operators develop this philosophy or understanding that they think it's okay to ignore alarms. And one might think, well, that's bad, that's dangerous. And of course, that is. And ideally, we would not want operators to ignore nuisance alarms. But from a human behavior and human factors point of view, we need to understand what's happening. And what is happening is you have a person whose role is to take in hundreds of pieces of information and data and make quick decisions about what's happening and what they need to do. So they have a lot of information to process. What a nuisance alarm represents to them is a piece of data that they do not have to worry about because they've seen in the past that it has not made a difference. So they ignore it so that they can focus on other areas that they believe are more important. And actually, from an operations point of view, this would be exactly what you would want an operator to do, to focus on where their attention is really needed and where it makes a difference. And nuisance alarms are causing them to think that they don't need to worry about certain alarms. So really the only way to change this is to eliminate the nuisance alarms. Part of the process is to be able to remove the nuisance alarms temporarily from the operator's view, and that's the process called alarm shelving, which we'll get to in a second. Now, again, thinking about the impact of nuisance alarms, if we want alarms to help us maintain plant safety and to act as an early layer of protection or a safeguard, then we are counting on the operator to reliably respond to alarms or a particular alarm when it occurs. Well, this is pretty inconsistent with nuisance alarms when operators are not responding to alarms. So certainly, if the operator were to not respond to a safety alarm, the probability of failure is 100%. So if you've got operators not responding to alarms, you are jeopardizing the reliability of that layer of protection. and in general would recommend that you should not take credit for alarms if you have issues with nuisance alarms. So you should not take credit for alarms as safeguards or as independent protection layers. So that's the impact from a human factors and performance point of view. So now let's talk about how we change things or deal with that. And that comes out of the international standards for alarm management, ISA 18.2 in the US and IEC 62682 internationally, defining what an alarm is supposed to be. Here you see the definition presented. This also forms what the criteria would be for evaluation of whether something is a legitimate alarm or not, which is applied during a process called alarm rationalization. So one of the ways to eliminate nuisance alarms is to evaluate whether it meets the definition of an alarm, and if it doesn't, to remove it from the control system. But of course, that process does not happen immediately, and it doesn't happen necessarily right when the nuisance alarm occurs. So what we want to talk about is that intermediate process of what we can provide to the operator to help manage the nuisance alarm situation until it can be fixed. Now, the standards also push and promote that nuisance alarms need to be taken care of very aggressively and addressed, defining some key performance indicators. What's the recommended threshold at which you should try to do better? And you can see for nuisance alarms, it's not too many, no more than 5 stale alarms, for example, on any given day. So that would mean if your alarm summary display is full of alarms or rolls over to succeeding pages, you're obviously not in compliance with what these standards would recommend. And of course, these KPIs are meant to drive behavior to improve the alarm system, eliminate nuisance alarms, and make the system more reliable. That's the whole idea of these KPIs. The other thing that the standards document or talk about is a concept called suppression. And this is where we get into the, okay, when we get a nuisance alarm, what do we do? What can the operator do? There's a process downstream which will need to occur to investigate what the problem is, to determine whether it's a design problem or a hardware problem or some kind of failure. But in the immediate time frame, we want to be able to alleviate the operator's distress from the nuisance alarm and remove it from view. So that's where suppression comes in. And the standards define 3 different forms of suppression, which is essentially hiding the alarm from the operator when the base alarm condition is present. The first type of suppression is called design suppression. That's where the control system does the automatic determination of whether an alarm should be presented or not, based on the status of the process or the state of certain equipment or what recipe is running. So it knows all that, and then kind of smart alarming wise will suppress alarms if they're not relevant. The second type of suppression is shelving, and that's the focus of this webinar. And that is meant for operators to temporarily suppress an alarm, to remove it from their view, to go onto what's called an alarm shelf. So it's kind of like a snooze button for an operator. And then the third type of suppression is called out of service. This is primarily meant for maintenance type purposes, longer term suppression. So the alarm, if it's taken out of service, means it's suppressed indefinitely, with no time limit necessarily until it's fixed or needs to come back. Now, with the 2014 publication of the international version of the standard and then 2016 update of ISA 18.2, one of the significant changes was new verbiage added that basically says that alarm shelving functionality is required functionality from a distributed control system. So that means that DCS suppliers now, as part of their new systems, need to provide this as an alarm management function. So part of what we want to do is talk about what does that mean? How could we take advantage of and use that function? And what does that functionality look like? What really is provided, and how can we leverage it? But one of the key takeaways is, if the international standards body thought it was important enough to make this a mandatory required feature, then it's probably a good idea, if you're an end user, to think about how you might take advantage of alarm shelving, or to consciously think about whether you can use it to your advantage and improve the operational situation. So more about shelving in particular. So the idea is, when a nuisance alarm appears and the operator knows at that point in time that the alarm is not valid or is only interrupting or distracting them, and they determine there's not a critical situation, then they can shelve or suppress the alarm, and that removes it from their view temporarily for a fixed period of time and puts it in a separate list of alarms. Now, this is different from disabling the alarm. If you disable the alarm, it's essentially gone forever unless you remember to re-enable it. There are no lists of disabled alarm statuses really in a control system. You have many alarms that would be disabled just because there are so many alarms provided. So to be able to show a list of which of the potential alarms in the system are actually disabled would be a gigantic list, and it would be difficult to know which ones are newly disabled that shouldn't be, and which ones are disabled and were meant to be. So one of the key features of shelving is that the alarm, although it's out of the operator's view, that's only temporary, and it's displayed, the fact that it's shelved is displayed on a shelved alarm list. So it's gone but not forgotten, and it will come back after that period of time is up. And of course, the whole purpose of shelving is, let's get this nuisance alarm out of the operator's view so they don't have to deal with it and get frustrated and used to needing to ignore alarms. Remove it from their view so that then the resolution process can take place. The underlying condition, whether it's a design problem or a hardware problem or a failure of some sort, can be addressed. And that then allows the operator to maintain their focus on true problems and true areas that need their attention. Now, there are two different types of alarm shelving, and each type handles different types of nuisance alarms better, or is optimum for certain types of nuisance alarms. Now, some control systems provide both types of shelving, others provide just one. And if they provide just one, it's typically the continuous shelving. So continuous shelving means once the alarm is shelved for a certain period of time, even if the alarm clears during that period of time, and if it comes back into alarm, it would immediately and automatically go back on the shelved list. So there will be no action on the operator's part to need to reshelve the alarm. So this is really good for chattering alarms, alarms that, may go into alarm for a couple of seconds, because if the operator had to reshelve every single time that the chattering alarm came in, that would be pretty pointless. So the continuous shelving essentially suppresses the alarm for a fixed period of time, and it stays there whether the alarm is active or not during that time frame. Now, the other type of shelving is called one-shot shelving. In this case, there's still a time estimate or a time range for the alarm to be shelved, but in this case, if the alarm clears before that time elapses, then we kind of rearm the alarm and put it back into the active array so that it can be available if the situation triggers again. So in this case, if the alarm were to clear and then come back into alarm, it would actually be presented to the operator. And in this case, it might be valid, and that's part of why you might use this different type of shelving. And where that comes into play, or where it's best used, is for a stale alarm. You can think of something that if it's been shelved for 6 hours and it's not being a useful alarm because of the operational state that the plant is in, well, if it clears, then it might mean that it's in a different operational state, and now that alarm is valid and useful again. So it rearms. So it allows you to deal with stale alarms and having them re-enunciate or provide the value of the alarm after it clears. So two different types of behavior related to what happens when the alarm clears and gets re-enunciated during the shelving period. So maybe you're thinking, okay, I'm interested in using shelving. I don't yet know what features are provided by the control system, but what are the things I need to talk about or figure out to make shelving work in my plant? So alarm shelving is something that you need to talk about in your alarm philosophy. That's now new content as well, to make sure that you are talking about how you are going to use shelving. It doesn't necessarily mean that you must use shelving, but you must talk about the shelving capability that's now provided by the control system providers or suppliers. How are you going to take advantage of it, or how are you going to use that in your plant? You need to document in that in your philosophy. So what are the things to consider? One might want to look at what alarms can be shelved. That's the first thing to think about. Maybe not all alarms should be able to be shelvable. Maybe the alarms that are the highest priority or are of a classification like a safety alarm or safety critical, maybe those alarms shouldn't be able to be shelved. So you go through that thought process of which alarms can be shelved, which alarms can't. Who can they be shelved by? Can an operator do it, or does it require a supervisor? Does it require some authorization? And how long should the alarms be able to be shelved for? Is it an hour, a shift, a couple of days? Those are the kind of things to think about and define as part of what would be your shelving process. Now, there's also a lot of procedural elements when it comes to shelving. Again, whether the operators, for example, need to get authorization to be able to do shelving. Things like, do you want them to record the reasons for why they're shelving, document that somewhere? You should also develop a routine where they're reviewing the list of shelved alarms on a regular basis, perhaps during shift handover, maybe tracking the number of shelved alarms to help make sure that shelving is being used appropriately. Make sure the operators understand what shelving is for and what they're supposed to do after they shelve an alarm, like generate a maintenance work order. So these are just some of the things that you might want to think about to tailor shelving capability to your operation. And there's even more in the ebook. So those are ideas for what to include in your philosophy. When it comes to being able to use shelving successfully, here are 5 best practices and recommendations. First, and probably the most important thing, is to train the operators on what the purpose of shelving is for. It's for helping to remove, nuisance alarms from view. It's not a substitute for acknowledging alarms. It's not a way to just quiet the alarm horn. There is a purpose for it, and if shelving is not used appropriately, you could have problems. You could have situations occur. So it's a tool that can help the operator, but they need to use it appropriately. Second thing is they should always be able to quickly and easily access the list of alarms that are shelved so they can see which alarms are suppressed. They might want to look at that before they start up a new process area or a new piece of equipment. Make sure if something's been idle for a while that there's no suppressed alarms on that piece of equipment before they start it up. So there's many good reasons why that shelved alarm information should be readily accessible for the operator, and they should be reviewing it on a regular basis. In fact, that should be part of your shift handover process, where the operator on shift ideally talks about what alarms are shelved or suppressed to the new operator coming on, and talking about why they've been suppressed and what that means as a part of the handover process. One of the other key things is to monitor the number of alarms that are shelved. We talked about in philosophy, you should have a metric, and it doesn't necessarily, I guess, matter what that metric is. It could be, no more than 20 shelved alarms at any one time. But the idea is you monitor it and see whether it's going up or going down. If you set a maximum number of 20, for example, and you look at it and the first week it's 15, and the second week it's 30, and then it's 50, and then it's 90, that means something's wrong. Because remember, alarms are going on the shelved list because there's some underlying problem that needs to be fixed. If the number of alarms on the shelf list just continues to increase over time, then that means that the second part of the process, the fixing of the issue, is not happening. So that would be something that would need to be corrected. And then there are, within most control systems, they have the ability to do reports and document the number of times alarms are being shelved and for how long, and you could look at that and should be looking at that to make sure that there's no alarms that are being shelved that shouldn't be, and to make sure there's no alarms that are just being shelved instead of fixing them. So those are some of the best practices, and those best practices would be applied to help address some of the common concerns when it comes to using alarm shelving. And this is a series of questions that we're going to look at that were actually posed on a survey on LinkedIn in the alarm management group several months ago. So one of the first concerns that was posed was our operators can't be trusted with alarm shelving. We would not feel comfortable trusting them. And to that is kind of a confusing comment or statement when you think about all the other things that we trust operators to do. They are essentially in charge of millions of dollars of equipment and process safety for multiple people, and significant operations and production requirements is all in their hands, and their decisions make or break those kind of financial metrics. So to entrust them with the ability to do alarm shelving or to use alarm shelving when required would seem to make sense, to be able to put that responsibility in their lap, as long as they understand what it's supposed to be used for. Second item was our operators will miss important alarms if we allow them to shelve them. And that's an interesting comment, because part of the reason for shelving is to actually help the operators not miss alarms. Because if you're not using shelving, then chances are you're just making the operators put up with nuisance alarms when they occur. And as we talked about, if you have nuisance alarms, eventually operators will ignore alarms and potentially not respond or miss important alarms. So the whole purpose is to temporarily hide alarms that would maybe cause the operator to miss alarms. And if the alarm is shelved, it's suppressed just temporarily for a fixed period of time. So after that time is elapsed, the alarms would reappear essentially, or be reactivated or re-alarmed to go off. The next concern was that operators would forget which alarms are suppressed. And that's a really good question, really good concern. And that's part of why the standards specify basically that if you provide alarm shelving as a functionality, then you need to also provide a list of the alarms that are currently shelved in the system. So, and you'll see that all the control system providers have implemented that, so that there's always a place for the operators to look at to know which alarms are shelved. And that would be either alarms that they have shelved or alarms that have been shelved previously and are still shelved. And of course, since the control system is maintaining and keeping track of that, that means that that list of suppressed alarms is always up to date. So there's no need to record and document that externally and make sure that statuses are changed when things are unsuppressed. The control system automatically maintains that status. Another thing to think about was alarm shelving will enable our operators to continue ignoring alarms instead of addressing the issue. And again, that's a reasonable concern, because that is something that could happen if the operators don't understand what shelving is for and don't use it correctly. So that goes to the training of operators to understand what the purpose is and how they use it and what the procedure is, as well as kind of the continued monitoring and auditing of alarm shelving performance to make sure it's being used appropriately and not to just cover up for alarms that are not working. So, because for sure, if you have an issue with an alarm, you could either deal with it or you can just suppress it or shelve it and it disappears. Well, that's not where we want the action to stop. We want the next step after the shelving to be, okay, now what? Does the operator go get maintenance? Do they call maintenance? Do they write a maintenance work order? There needs to be some follow-up step so that the suppression is just removing the alarm from view and then allowing the underlying issue to be addressed in a timely fashion. And the last one was, we don't need to use alarm shelving, or you should never need to use alarm shelving if you do a proper alarm rationalization or you use dynamic alarming. And this is an interesting point of view. It's basically saying that if you do proper design of your alarm system and rationalization, that you should never get nuisance alarms and you should never need shelving. Well, that's not true, because no matter how well you design or engineer the alarms, there are certain situations that will occur that will result in nuisance alarms. For example, from equipment failing or wearing out. Those will cause hardware errors, those will cause faults, those will cause failures that can present themselves initially as nuisance alarms. So there's some things in some scenarios, process changes could be others where you're using different feedstocks or whatever, or severe weather, you're hit with a cold spell or a hot spell that's a little bit beyond where the equipment was designed for, that you'll end up with nuisance alarms that there's no way that you could prevent from occurring during design phase. Similarly with dynamic alarming, which is a way to modify the alarm's behavior depending upon the state that you're in. You can't anticipate all of the potential states, and again, ones that pop up related to failure and temporarily performing the operation in a little bit different way from normal. Shelving allows you to deal with those temporary situations. So it's impossible to design to eliminate all nuisance alarms. You can certainly minimize the potential for nuisance alarms and minimize the number of alarms that you would get by doing a thorough and proper rationalization, and that's what you should do. But then there will be nuisance alarms that occur, and that's where alarm shelving still would be required or beneficial. So now let's switch gears and talk about what is it that the control systems are supposed to provide for alarm shelving. So what are the requirements that are in the ISA and IEC standard when it comes to alarm shelving? First, from an overall point of view, as I mentioned earlier, the function or the ability to shelve alarms is a required function from these standards. In addition, there needs to be a way to display the list of alarms that are shelved and provide some time limit or timeout for the alarms to only be shelved temporarily. There should also be records for when alarms are shelved, and as a best practice or a recommendation in this case is the control system should have some methodology that when a bunch of alarms are unshelved or unsuppressed, that doesn't result in a flood of alarms. So those are some of the key requirements for overall alarm shelving functionality. Now for the shelved alarm display, this is some of the requirements here, and I won't necessarily go through all of them. Kind of makes sense in terms of a typical alarm display in a control system. What would it have? It would have the tag name, the alarm description, but let me just point out some of the more key pieces of information. The first one is the alarm status. So what does that mean? That means, is the alarm active right now? Would it be active if it wasn't suppressed, or would it be inactive? And why is that useful? Because that tells you if you were to unshelve the alarm at that point in time, would the alarm come right in or would it be clear? So without that, you don't know whether you've got a live alarm that you're reactivating or an alarm that's clear and bringing it back in. So that's the benefit of that. The other thing I want to point out is the very last requirement, which is the ability to show how much time is remaining. Again, shelving is a temporary suppression for a fixed period of time. So knowing how much time is left before the alarm is unsuppressed can also be very useful. So that is a recommended or required feature, or the alternative is to show the date and time that the alarm was actually suppressed. So those are the requirements for the displays. And then in terms of the functionality of an alarm display, again, a lot of this is what you would expect for a typical control system alarm display with sorting and filtering capability. Just a couple things I do want to point out is a recommendation. So this is not a requirement. If it's REC, that means it's a good practice, it's a good thing to do, but it's not required. The first one I want to point out is the ability for the operator to enter a reason as to why they shelved an alarm. So that's a good practice. The ability to unshelve a group of alarms at once, so not just one at a time, and then some links to take you to relevant displays from the alarm. So those are the requirements. You can see it's actually shown in a checklist like this, with the idea that you could sit down with your control system supplier if you want to know more about how the functionality of alarm shelving works in your system, and you can go through these various requirements and features and functions to have a better idea on what you have in your system. So now let's talk about, at a higher level, what is the alarm shelving implementation in some common control systems. And for this, we've looked at 6 different control systems that we've had the pleasure of doing various projects on. So we've developed a good expertise as to how they work and recommend to people on how they should leverage alarm shelving for these different platforms. So the first one is ABB System 800XA. And for their implementation, shelved alarms or alarms can be shelved from the standard alarm summary display via right click, and that will call up a dialog box from which the operator has several choices related to shelving. The first thing is they get to choose what is the reason for shelving the alarm, and that choice comes from a predefined list that is set up in engineering mode. So they can choose the predefined reason. That's the first step. The second step is to determine how long they want the alarm to be shelved for. And in this case, again, it's a predefined list of times to choose from. That could be either fixed duration or actually could be infinity, meaning there is no time limit. So the operator has the ability then to set the time they want the alarm to be suppressed for. And then they also have a choice of whether they want that particular alarm to be shelved using a continuous shelving or one-shot shelving. And as we talked about, each of those has kind of a different ideal application. Continuous shelving for chattering alarms and most alarms in general, and one-shot shelving for stale alarms. So depending upon what's happening, the operator can choose the time duration and the type of shelving. They can also enter a comment, a free-form comment, so that can be built into the dialogue to kind of force them to do that. And that's available for them to add additional information as to why they've shelved the alarm. And then also to improve the traceability and authorization, one can actually set up roles and responsibilities so that you must authenticate or log in and provide a password essentially when you shelve an alarm. So that could be something that the operator needs to do alone, or it could be the operator and a supervisor, so double signature, double authentication, but that can be set up and become required. And you could see that for certain operations that might be appropriate. And then the alarms that are shelved, the list of shelved alarms and the status of them are available throughout the HMI application. There are alarm bands shown on the process graphics, and each of those represent a certain process area, indicating whether there's active alarms there, how many active alarms there are. It also indicates whether there are shelved alarms from that area. And if there are, you can click on that portion of the band and it will call up the alarm shelved list for that process area. You can also get to the list of shelved alarms from the alarm summary display. So now let's take a look at the Emerson DeltaV system. So what's unique here is that every alarm can be assigned its own suppression time. So essentially, for each alarm, you can determine not only whether you're going to use shelving or not, because if you set the suppression time to 0, that effectively disables it, but you can also define how long the alarm would be suppressed for. So pretty rigorous functionality when it comes to defining which alarms can be shelved and not. The maximum shelving time is 999 days, which was the default in earlier versions of DeltaV. That was actually changed in version 13 to 8 hours, which is more in line with shelving. And then as part of the shelving process, the operator can again select from a predefined list of reasons for shelving the alarm, and then that would get added to the alarm log or the event chronicle. And to make sure it's clearly differentiating alarm shelving versus the out of service form of suppression, those are actually two different and distinct commands from the HMI and from the alarm faceplate, for example. So one can set up the system where operators have the ability to shelve alarms, but they don't have the ability to take the alarm out of service, because that's a little bit more significant. That's a long-term suppression with no time frame yet. So perhaps you set it up so that only maintenance supervisors or engineering team can take the alarms out of service. So you can control based on roles and responsibilities who has access and ability to do the different types of suppression. When it comes to displaying the suppressed alarms, the shelved alarm list in DeltaV actually can be grouped in with the other forms of suppression. So you could have one suppressed alarm list that has alarms from design suppression, alarms from shelving, and alarms that are out of service. And here in this screen capture, we're showing actually alarms that are both shelved, and you can tell because it's displaying how much time is remaining before the timer is up, and alarms that are out of service where there is no end time. So those are shown simultaneously in the same shelved alarm list. This has flexibility to configure so that you have separate displays for shelved alarms versus out of service, if that's a better way to view things. And then you can even go further with shelved alarm lists based on certain categories of alarms, either the highest priority alarms or maybe alarms that are of a certain classification, like safety alarms or environmental critical alarms. You could set up a display that shows any alarms with that classification that are shelved, because that would be very important to know, because if an alarm, a safety alarm, is being shelved, then it's essentially like you're bypassing a safety function almost. So a lot of capabilities there. So now let's look at the Honeywell Experion system. And again, operators can shelve alarms from an alarm summary display. Right click, it calls up a dialog box that gives them a lot of options for that particular shelving command. So they can define from a preset list of reasons for shelving, select from that list, and based on the selection, there's also behind the scenes a range of potential shelving times that can be defined or specified by the operator. So for example, if it's a nuisance alarm, in this example, it says that the alarm could be shelved by the operator from either anywhere between 30 minutes and 8 hours, with the default being 2 hours. So depending upon the reason that is selected, the operator may have different bands of allowable shelving time, but the operator has the ability to select how long they want to shelve the alarm. And you can see that they can also check the box to change whether they're using a continuous mode or a one-shot mode for the shelving type. Operators also, when they shelve the alarm, can enter a free-form comment as well to document more details about why the alarm is shelved. And then one of the strengths of this system is the ability to display within the process graphics the status of shelved alarms. So if you look at a process screen, instead of showing an active alarm being colored, you'll see a symbol that tells you that there is a shelved alarm present for that tag. And it also actually helps differentiate whether what the priority of that alarm would be. So you can look at a screen and not only know what alarms are active, but also know that there are some alarms that are actually suppressed at that point in time. For the Rockwell Plant PAX system, alarm shelving can be enabled or disabled on an alarm by alarm basis. So quite good control over what alarms can be shelved and which ones cannot. And then in addition to enabling or disabling, you can also set the maximum shelving time separately and individually for each alarm. So 8 hours is the default. You could set that for 8 hours, 24 hours, whatever. And then the idea is when the operator goes to suppress or shelve that alarm, they have the ability to set the shelving time anywhere they want between 0 and essentially up to that maximum. They can also enter a free-form comment in to document why they shelved the alarm. And similar to what we just talked about, a symbol on a process graphic, if an alarm is active and it's shelved, there'll be some indication of that status provided within the symbol on a process graphic. Next, we'll look at Siemens PCS7 system. And for this system, there's actually a single setting to enable or disable shelving system-wide, and a single timeout value. So all alarms use the same shelving timeout, and that can be a maximum of 10 days. You can see here it can be set anywhere from 10 days down to 1 minute, basically. Now, for the Siemens system, they have two different shelved alarm displays. They have one that's of alarms that are shelved but are not actually active at that point in time. So the alarm is not on, but it's suppressed. So you have that, and those are called list of messages to be hidden. And then there's a separate list, which is alarms that are active and are shelved. and that's the hidden messages list. So again, it helps you to understand whether the alarm is actually active or not, and in that case, then if you were to unshelve the alarm, what would happen? Would you now have an active alarm situation, or is the alarm actually cleared and it goes back to normal? And again, similar to the other systems that we looked at, when an alarm is shelved in a PCS7 system, the operator can enter an optional comment. And then the last system that we want to go through and talk about is the Yokogawa Centum system using CAMs, which is an optional add-in that allows shelving and powerful filtering and display capability. So in the Yokogawa system, alarms can be shelved, or shelving can be enabled on an individual alarm by alarm basis, including for SIS alarms, for which they're disabled. Shelving is disabled by default. Now, the way shelving works in a Yokogawa system is there are actually predefined folders that represent different timing and types of shelving. So behind the scenes, as part of the setup, different alarm shelving combinations are set up. So here you see one that is 1 hour duration and it's one-shot shelving. And then there could be another one which is 8 hours and continuous shelving. So those shelves are set up as part of the system beforehand, and then when a nuisance alarm comes in, what the operator does is they can drag and drop the alarm to the appropriate bucket for alarm shelving. So essentially at that point in time, they are deciding whether they want it to be a continuous or a one-shot, and the maximum amount of time they want it to be shelved based on which shelving folder they drag the alarm to. Now, the maximum shelving time in the Yokogawa system is 24 hours. And when the alarm times out and it's time to be unshelved, there's visual indication provided, and then the operator needs to go and grab the alarm and essentially drag it back to the active alarm list to clear the suppressed alarm. So that's the overview of alarm shelving implementation. You can see there's a lot of good and very useful functionality to take advantage of. You can also see that everyone, or all those suppliers, implemented functionality a little bit differently. So one of the recommendations is, before you create your philosophy to define how you want to do shelving, make sure you do some research to understand how your control system supports it, so that the requirements that you specify can be implemented in the control system. So then, in summary, I truly believe that alarm shelving is a very critical tool for the operator to help them deal temporarily with nuisance alarms. I'm not the only person that feels this way, because that's why the standards bodies put that as a required function. Certainly, if you don't use alarm shelving and you have nuisance alarms, then operators are going to become desensitized to alarms in general. That will increase stress tremendously. It can cause them to distrust the control system. So using alarm shelving to alleviate the nuisance alarm problems temporarily until they can get fixed is a pretty powerful functionality. As I mentioned, it is required functionality from the standards. So kind of to summarize, what I would recommend is, if you have a control system and you're looking at implementing shelving, download a copy of the ebook, talk about that in a second, and review the capability that your control system supplier provides. And some of it might be of recent vintage, so you may not be aware of what's available. And then based on what's available, think about, from an operational point of view, what makes most sense in terms of leveraging the shelving, and then go for it and implement it, and put that into your alarm philosophy in the way that you want to, and it'll provide a mechanism for dealing with nuisance alarms. And as part of that, make sure that you are including the necessary checks and balances to make sure that shelving is used correctly and not being abused. Because certainly one could just continue to reshelve an alarm rather than actually fix the underlying problem. And that's not what we want to have happen. That's not what shelving is meant for. But of course, without some review and oversight to make sure that it's being used properly, that could happen. And it could also happen that the underlying issues for what's causing the nuisance alarms aren't being corrected, aren't being fixed. And that would be part of the process that needs to be addressed as well. So, as I mentioned, much of the material in this webinar is taken from a new ebook that Exida has published. This is the link for downloading that ebook. It'll also be included in the email that comes out with the link for downloading the presentation. So if you want to learn more about alarm shelving and get some of the more of the details, I would definitely encourage you to check out that new ebook. And in terms of other interesting things that I want to make you aware of, we do have a survey going on right now, which is an industry benchmark on determination and usage of safe operating limits. So if that is part of your role at your company or you're familiar with that, I would encourage you to follow this link here that's embedded in the presentation. Follow the link and complete the survey. It takes about 15 or 20 minutes. We're trying to understand what people do as best practices and such. And then if you give us your email, we'll send you a copy of the results. And then the last thing I wanted to mention that we're pretty excited about is a new program for training when it comes to alarm management to supplement the training classes that we have on alarm management practices and principles. We now have a certificate program, which means if you take the training class and you pass the examination that goes with that, that demonstrates that you've achieved a good base level of alarm management proficiency. So we would give you a certificate as part of that, similar to what's done with the CFSE program and FSP, as well as the cybersecurity certificate and certification program. Now there's one for alarm management as well. And the very first, or the inaugural class where the certificate program will be part of that, is being conducted in September 18th, or the week of September 18th in Orlando, Florida. There's information about that on our website if you're interested. Of course, you take the class, then take the exam, and after the exam, if you pass, if you get greater than an 80%, then you would be granted the certificate indicating that you're an alarm management practitioner. So we're pretty excited about that capability. So at this point, I'll say thank you very much for attending. Going to check to see whether we have any questions. I don't think we have time to answer them right now. So what I would just ask is, certainly if you have questions, take a minute and enter them now, and then I'll get a copy of them afterwards, and I'll go through and answer all of them. And those questions and answers from both this webinar and the earlier session will go out as part of the email follow-up for the download of the presentation and the ebook. So if you found this interesting, and I hope you did, and you're interested in learning more about alarm management, please check out our other pre-recorded webinars. There's a whole bunch of them on the website and on YouTube, as well as other disciplines as well, functional safety, cybersecurity, for example. So please feel free to check out the content that we have. Hopefully you'll find it interesting and useful. And thank you very much for attending. If you have any questions, my email is listed at the bottom. And at this point, I'll say thank you and have a good day, have a good evening, or have a good morning.